Welcome to Robo's Physics Adventures. Today Robo is learning all about speed and velocity. Robo and the class are on an adventure to learn about the story of the tortoise and the hare. Students start watching the race between the two animals. When the race starts, the hare quickly reaches a maximum speed and travels at a high constant speed. The tortoise reaches its maximum speed, which is significantly slower than the hare. After about the halfway point, the hare finds the race too boring and decides to take a short nap, thinking that once it wakes up, it can easily pass the tortoise and embarrass it in front of the audience. The hare goes to a quick stage of deep sleep, and when it wakes up, realizes that the tortoise is almost at the finish line. The hare tries to reach the tortoise but doesn't manage and loses the race. Robo logically cannot process the behavior of the hare, and his group members Melissa and Robert help Robo understand a bit about pride, ill intent, and irony. Mr. S asks students to sketch the position time graph for the tortoise and the hare. Robert analyzes the motion of the tortoise. The tortoise covers a small distance every unit of time until it reaches the end point. When connecting the points on the position time graph, Robo notices a straight line with a shallow slope. Mr. S tells students that the average velocity is the displacement of the object between 2 points divided by the total amount of the time it took for the object to move between them. Graphically, the average velocity of the tortoise from the starting point to the end could be calculated by the gradient or the slope of the line between the 2 points of interest in a position time graph. Here, the rise represents the change in position or the displacement, and the run shows the change in time. Since the slope is rise over run, it equates to the average velocity in this particular case. Robo then processed the information and linked it to the last lesson. Robo mentioned that this would make sense because the slope of this line is very shallow, meaning that the tortoise was traveling at a low average speed, and since the slope is positive and east is our positive sign convention, it was traveling to the east. The group agreed. Melissa then started looking at the hare's position with respect to time. The hare quickly reaches halfway point and then stays there for a very long time. Then the hare travels again very fast towards the end point and reaches it just after the tortoise. As Melissa is connecting the points, Robo notices 2 straight lines with a very deep slope and one region that has a flat slope. There was a bit of confusion within the group as there were multiple intervals to analyze. Mr. S mentioned that it's better to analyze this motion in intervals. In this case, the hare has different instantaneous velocities at different points in time. The instantaneous velocity is the rate of change of position per unit time. Graphically, to determine the instantaneous velocity from a position time graph, we can draw a tangent at the point of interest and calculate its gradient or slope. Mathematically, we can also take the derivative of the function at that point, a concept that will be studied in the future if you take calculus. Here, we notice that the hare travels at 3 different velocities. For a constant velocity, the gradient of the tangent can easily be determined by the gradient of the line. Robo then thought out loud. This would mean that initially the hare is traveling fast in the east direction because of the steep positive slope. Then the hare stops because the slope is 0. Then it travels at the high speed to the east again to get to the finish line because of the positive steep slope or gradient. Mr. S agreed. He also mentioned that you can still determine the average velocities between any 2 points on the graph. For regions of constant velocity, the average velocity and the instantaneous velocities are the same. Mr. S then said, let's use some numbers. The end position of the race was 180 meters to the east of the starting point. The tortoise finished the race after 30 minutes. Sketch the position time graph and calculate its average velocity from the start to the end point. Melissa sketched a position time graph showing all the important information. She then used the slope between the 2 points to calculate the average velocity of the tortoise. The rise here was 180 meters and the run was 1800 seconds. This results to 0.1 meters per second to the east. Melissa then did a quick research to find the average speed of the tortoise to be within range. Mr. S then said the hare covered 140 meters in 10 seconds and then started running towards the finish line 2 seconds before the tortoise finished the race. Sketch the position time graph and calculate the following. The instantaneous velocity at time 5 and 70 seconds and the average velocity between time of 0 to 70 seconds and the entire trip. Robert started by sketching the situation and labeling the important information. He then sketched the tangent at 5 seconds and 70 seconds and realized that he can use the slope of the straight line to find the instantaneous velocity. The instantaneous velocities at 5 and 70 seconds were found to be 14 and 0 meters per second to the east respectively. Robert then drew a straight line between 0 to 70 seconds and calculated its gradient and therefore the average velocity to be 2 meters per second to the east. Robo asked, could we average the 3 average speeds to determine the average velocity for the entire trip? Melissa said, that would not work because the hare is traveling at these velocities for different intervals of time and therefore the average will not be a good representation here. Robert then drew a straight line connecting the first point to the last point for the entire trip, assuming that the hare got to the finish line very close to the tortoise. The slope of this line was found to be 0.1 meters per second to the east. The group was in shock, knowing that even though the hare could travel at speed of 14 meters per second, its average velocity was significantly less due to the time it spent sleeping. After the race was completed, the hare realized its mistake and came to apologize to the tortoise. The hare picked up the tortoise and carried it toward the starting line to celebrate the achievement. After a discussion of acceptance and kindness, Mr. S asked students to analyze this motion of the hare qualitatively. Melissa started drawing tangents at different points on the position time graph. Robert noticed this and said, you must be doing this because the slope of the tangent will give us an idea about how the velocity is changing over time. Melissa agreed and said, it seems as though the velocity increases during the first 10 seconds, meaning that the hare is speeding up. Between 10 to 20 seconds, the velocity seems to be constant. Between 20 to 40 seconds, the hare's velocity is decreasing to 0, meaning that it is slowing down. Robo remembered the previous lesson. Robo said, since the gradient is always negative and our sign convention is positive in the east direction, this means that the hare is traveling to the west during the whole time. Robert and Melissa agreed. Mr. S now asked the students to calculate the average velocity for the entire time. Robert said that the average velocity can be determined by the slope or gradient of the line between any 2 points. Since we're considering the entire time, we have to choose our points to be the start and the end positions. He drew a straight line between the initial point and the end point and then calculated the slope by dividing the rise by the run. He got negative 180 divided by 40, resulting in negative 4.5 meters per second in the east or positive 4.5 meters per second in the west direction. Mr. S said, "We can also divide the displacement by the change in time to determine the average velocity." Robert tried this out. He knew that the final position was 0 and the initial position was 180 meters east. To find the displacement, he subtracted the final position by the initial position to get negative 180 meters to the east direction. He then divided this by the total time of 40 seconds to get the same answer as before. Robo was wondering about the average speed. Robo said that in the last lesson, they learned that the speed is the magnitude of the velocity. Mr. S said that this is only true about instantaneous velocity and speed. When it comes to average speed, you need to pay attention to the distance traveled rather than the displacement. The average speed is always the total distance traveled divided by the time it takes to cover that distance. Robo then analyzed the situation and said, in this particular case, since there is no change in direction, the distance happens to be 180 meters. This is how far the hair traveled. We can take this number and divide it by the total time of 40 seconds to get 4.5 meters per second as the average speed. Even though in this case the average speed and the velocity have the same magnitude, this is not always the case and we have to be careful when there is a change in direction. Robert, Melissa, and Mr. S agreed. For the final task, Mr. S asked the group to estimate the instantaneous velocity and speed at 30 seconds. Mr. S said that the command term estimate means to obtain an approximate value and that the range of values will be accepted as a final answer. This is because when drawing the tangent by hand, it's very difficult to get a perfect line that would match a perfect answer. Robo reminded the group that instantaneous velocity is the rate of change of position with respect to time, and it can be calculated by the slope of the tangent. Melissa then drew a tangent at 30 seconds and chose 2 points on the graph and used them to estimate the gradient. She found the rise to be about negative 95 meters and the run to be about 30 seconds. Therefore, the slope was found to be about negative 3.2 meters per second east or positive 3.2 meters per second to the west. Robo said since the instantaneous speed is always the magnitude of the instantaneous velocity, this would mean that the instantaneous speed at 30 seconds is about 3.2 meters per second. The group and Mr. S agreed. The animals partied and enjoyed their time as Robo and its class returned back to the school. This was a big day of learning for Robo. Robo had learned about average and instantaneous velocity and speed. It had also learned about graphical techniques that can be used to obtain these quantities from a position time graph. Robo had also learned about emotions and feelings from the behavior of the animals. Robo had to review the content and get some rest in order to make the adequate circuit connections so that it can retain the information long term. Robo was looking forward to the next adventure.